Hello, my name is Doug Ropp, coming at you from Cambria Heights Middle School. Today's presentation that we're going to be putting together is about a multidiscipline project that we put together involving robotics, 3D printing, and coding. Throughout the entire project, we tried to have a very strong focus on career-oriented opportunities that students could get into based on the introduction of this project to those possible fields for them. We implemented 3D printing into our project by having students create 3D objects for our robotics course. The students got to use multiple software to use with multiple robots that we have at our school district. The idea of the students 3D printing helped with the idea of creation and the idea of, again, career-oriented jobs. And we then exposed the students to other forms of 3D printing beyond what we did with our project. This includes 3D printing in the form of bricks that is being used in industry and construction, 3D printing concrete foundations and buildings, which is again a possibility of how buildings are going to be made in the future, and students are getting a quick introduction into that possible future with our assignment. And again, the specific parts that they are 3D printing are for the robotics course, but it's part of the larger project that the students are exposed to 3D printing as a possible career option and as a definite future building material. The next aspect of our project that we will be looking at in this video is the students built what they 3D printed using a manually controlled robotic arm. Now, sometimes the students had slight flaws, as you can see there, but for the most part, the students got to work with the dexterity of the robotic arm, and the robots are sharper image remote controlled robots that the students move on multiple axes, and you can see that the tread spins independently or at the same time to move the robot in one direction or another. The students assembled what they had 3D printed, as well as wooden blocks that we had cut in class in the shop, and then the students were able to then paint. All of that work with the robot constructed the course that the students are then going to code their other robot to go through using block coding. So there was a very big difference between the robots that were manually controlled by remote control and our robots that we used in block coding. Now, this aspect of our project had a strong emphasis on careers that utilize such heavy equipment like a bulldozer, agricultural equipment that is manually controlled, not the type of coding like block coding that we will show later, but the type of coding that we see commonly in industries like mining and farming. And it's also being used in many other industries like flying a drone or in heavy equipment operating. So we are attaching some videos to show what these types of careers look like, and we're trying to give students exposure to these types of careers in the future. Upon construction of our course, which we called the zoo, because a lot of our 3D printing centered around zoo-type animals, the students constructed it using the remote-controlled robots in preparation for our Q robots that run off of block coding. As you can see, the students 3D printed animals, stars, light posts to try and make it as scenic as possible. Plus, it also gave just about every student the opportunity to 3D print something. So with our zoo theme and our wooden blocks in place and our fencing in place, we are ready to go and run the course. The course is going to be run by our Q robots that the students generate block coding for. And the student block coding is going to include a little bit of target practice as well. In addition to the zoo atmosphere, we were also able to 3D print targets for the students to actively engage with our Q robots that are equipped with dart guns. So it added a whole nother element of the students moving through the course with not just trying to maneuver around blocks and fences and animals, but to try and obtain target points as well as they go through the course. So each student participated in making the course, each student participated in the construction of the course, and each student gets the opportunity to attempt coding and firing our robot while on the course. So this is our robot, the Q, getting ready to run the course using the iPad, which has the Q app downloaded on it. The robot is connected to the iPad using simple Bluetooth, and we're going to get into the coding at the end of the video, and we'll show you exactly what block coding is, because I've been continually using that term and you haven't necessarily seen what I've been talking about whenever I say we use block coding for this robot. But this robot is now going to execute the course following the code that we have created for it using the app. The robot is going to make movements and turns and travel set distances that are programmed within the code. One of the things we learned very early on was that we needed to start the robot from the exact same start point every time to help the codes run the same every time. So the robot is going to work its way through the course, firing 2 darts at each target, 2 at the white, 2 at the blue, and 2 at the red. As the robot is navigating through this course, the students have to make measurements in centimeters. It has to make measurements for angles and degrees in turns to both fire the darts and to move the robot. One thing we also learned is that sometimes you have to clear the darts off of the course. So the robot moved forward as it was coded to, makes the turn, moves forward, and is going to make another turn. Again, these are all calculated and measured, and the students are executing that, and each student gets a chance to generate one of these codes. So again, this whole time there are angles and changes that the robot is executing based on what it's coded to do and trying to complete the course while getting into position to fire at the target. In general, this is the software or app that the Q runs on, downloads onto an iPad, and the students then use the actual option on the app to make stock coding, and that's underneath the control. The control aspect of this app is to run the robot like a remote control, like we did with the robot arms. We're not really interested in doing that with the Q robot. The Q robot is our students' opportunity to work on block coding, which we'll see here in a moment. But this app is very user-friendly. It allows the students to use it on a touchscreen device that they are mostly comfortable with already. And then they are able to stack up the coding, which we'll see here in a second. But the code aspect is the one in the top right that the students will generate their code with. The control is on the bottom, and that's whenever you allow the students to navigate it like it's a remote control car or like our robot arm that we built the course with. So the students will stack code. So on the left taskbar are different actions, and the students will stack them in the order that they want the robot to execute those codes. Each command is then calculated in a measurement or an angle or some type of change. And what the students will go through is several options or several versions of their code. Sometimes it'll mess up, sometimes it'll do great, sometimes this turn is too sharp, so they'll go back in here on the app and tweak the code. So they simply select off of the left taskbar drag and drop that command and stack the code into all of the commands combined that they want the robot to execute. So, in conclusion, I hope that you enjoyed our presentation and the incorporation of 3D printing not only as a fun activity in school, but as a potential career path. I hope you enjoyed the robot that is remote controlled, as students can see that as a possible career path and also something fun to do. And lastly, I hope you enjoyed the Q robot coding as, again, a possible career path and something the students got to enjoy. Thank you very much.